Hello class, this is Mr. Callen, and I'm going to be walking you through the open-ended review solutions. So what I want to do is I'm going to first start off with, I'm going to probably do one page at a time, and there'll probably be about 4 videos because there are 4 pages. So on the first problem here, we see that a man earns $2,500 the first year he worked, and he received a raise of $600 at the end of each year. During what was his salary during the 15th year? So what we want to do is we want to consider this to be an arithmetic sequence where a to the n is equal to the first year plus the number of years minus 1 times the difference between years. That will tell us what our 15th year was. So then after we do that, then we're going to find out what the sum of the 15 years was using the arithmetic summation formula, which is S to the n equals the first year plus the last year times the number of years divided by 2. So what we'll do is, because the first year was 2,500, we'll just put into the equation, since we're looking for the 15th year, 2,500 plus the salary, the difference each year, the common difference is 600. And the number of years minus 1 is 14. And what this stands for is the number of differences in our sequence. So the 15th year will be, now for this part of the test you're going to need a calculator, so I'm going to calculate this. So the first part of the test, which is multiple choice, you won't have a calculator, so the numbers will be adequate so that you won't have to, or I'm sorry, appropriate, so you won't have to use a calculator. But the second part you will have to use a calculator. So anytime you feel the need to use a calculator or make a graph or use any technology to help you with the problems, go right ahead. So the 15th year, the man was up to $10,900. That was his last year's salary in the year 15. And now when we add up all 15 years by using this sequence, this summation formula for series, we would just put in the first year plus the last and multiply it by the number of years divided by 2, which would be 15 divided by 2. And the answer should be, and I'm just going to pause it while I put that in the calculator. And my final answer for the 15 years, the sum of all 15 years, was $100,500. The next one is a geometric sequence. In this one, the pendulum is here is at its center point position, and each time it goes back and forth, the distance is decreasing by 2/5 its previous distance. Find the total distance it travels before coming to rest. So this is considered to be an infinite geometric series. What's going to happen is on the first swing, it swings 5 on its first oscillation. So that means it's going to go this way 5, and then it's going to go this way back 2/5. So 2/5 of 5 would be 2. And then this way it's going to go back 2/5 of 2, which would be 4/5, and so on. So the sequence of numbers we're going to be adding up will be 5 plus 2 plus 2/5, 4/5, plus, and this will be 2/5 times this will be 8/25, and so on. Because it's a geometric series and the geometric ratio is less than 1, we can use a summation formula for an infinite series. And this is for, you should write this formula down, for infinite geometric series summations. It's equal to the first sequence term divided by 1 minus the geometric ratio. We proved this in class, and you should check your notes on this. There are a couple other formulas associated with geometric sequences in series that you should also write down in your note card, just so you don't find that you've come up short when you take the midterm. And so when we finally plug in all the information for the infinite series, the first one was 5 over 1 minus the geometric ratio was 2/5. And I'm just going to do the math because that's going to end up being 5 divided by 3/5, which will end up being 25 over 3 meters. And if you do that, that will end up being 8 1/3 meters on the calculator. So that's how you do that problem. I'm just going to pause the camera so I can clean up the screen, and we'll start working on number 3. Okay, on number 3, it's a piecewise function, and for this part, it's where x is greater than 1. So wherever x is greater than 1, you're going to be plotting the line 4, which is just a horizontal line. And wherever x is less than 1, notice I filled this in because it had greater than or equal to. And wherever x is less than 1, we're going to plot the line -5 minus x. So y equals -5 minus x. Now this is a linear equation. You should know that by now, but we need a few points to plot it. So I'm just going to plot an xy table, and I'm going to put in the point 1, and then values less than 1, 0, and -1. And when I plug them in, I'm going to have, when I put 0 in, that's easy, I'll get -5. When I put 1 in, I'll have -6, and when I put -1 in, I'll have -4. So I plot those points. So at 1, I'm going to be at -6, which will be all the way down here. I'm doing an open circle because it's not equal to the line there. And I'm going to now plot 0. At 0, I'm at -5, and at -1, I'm at 4. So now I have enough points to show my line, and that would be my piecewise function that they're asking for in number 3. Now in number 4, the example problem has this coefficient of 1/2, and basically they want us to graph, this is a graph of f of x right here. So they want us to do a transformation left-right of this graph, and they want us to move it up 3, and then the height of the graph will only be half as much as it normally is. So we may want to take our time graphing this. So I'm going to first graph just f of x moved to the right by 1 and up 3. So I'm going to pause it while I do that, and then when you come back, you'll see that graph moved up 1, right 1, up 3. So I plotted these points, and you just basically would take each point one at a time, and you would look at their coordinate, and you would change them so that you increase the x value by 1 by moving it right 1, and you change the y value by 3, moving it up 3. So for example, this point at -2, 2, I want to increase the x value by 1, so it should now move to -1, and it should go up 3, so it should be at 5. So the new mapped coordinate should be at -1, 5, and that's where that point is. Now, you do that for all your points, but then you have to deal with this little 1/2 factor. So what that 1/2 means is that the function, all the y values that it had are half as much as they were. So this point that was at 0 is going to stay at 0. So the next point would, all these other points would just be squeezed by a factor of 1/2. So it would basically create this like compression, this look of compression by squeezing all the values towards the midline of this function by 1/2. So I'm just going to graph over top of this where the new points would go, and as you can see, I'm just taking all the values and I'm moving them closer to that imaginary axis by 1/2, and that creates that compression effect. So the final graph would be this green one, and that would create the 1/2 of f of x minus 1 plus 3. So that would be my final graph. Since in class we didn't do these stretch factors, that's not going to be, I would like to see when you graph these, I would like to see your left-right translations, so you get to the right, you get to the red graph, and then if you can show me how you take care of the stretching or the compressing on another graph, that would be something I would look at separately. That is the end of the first page, so I'm going to stop this video and process it, and then we'll start working on the next set of video pages. So please, tune in for the next few pages if you need help with those, and we'll talk to you soon. Take care.